Hello, I am Nikhil Kelshikar, Senior Director in VMware's Networking and Security Business Unit. And today I'm here to give you a brief introduction to VMware NSX, VMware's network virtualization product. During this session, you will be getting a quick introduction to how NSX is a part of the software-defined data center and the key value NSX plays within the SDDC. We'll learn about three key use cases of NSX: microsegmentation, self-service IT, and extending beyond the data center to use cases such as disaster recovery. And we'll be talking about NSX and the role it plays in building out a converged infrastructure. So with that, let's get started and talk about how NSX plays a role in the software-defined data center. What is a software-defined data center? In a traditional data center infrastructure, all the intelligence of how the system operates has been built into the hardware itself, right? You have intelligence in the hardware, you have multiple different vendors, and each vendor has a dedicated vendor-specific management. And you can have multiple different devices. You are doing manual device-specific configuration and management. However, with the advent of virtualization and as more enterprises virtualize their entire infrastructure, we have the ability to move that intelligence into higher level, into the software itself, closer to where the compute and the applications reside, effectively giving us the operational model of a virtual machine for the entire data center. We can now move from a manual configuration model to an automatic configuration and management model for your entire infrastructure across compute, storage, and networking, dramatically simplifying what the infrastructure looks like. Right now, you can look at your infrastructure as pools of compute, pools of network capacity which can be scaled out, and storage capacity, allowing you to get better performance, the best price, and a simplified operational model for your entire infrastructure. In fact, this idea is not very new. The anatomy of the most efficient and agile data centers is software-defined. When you think of some of the largest data centers in the world, they're able to operate the infrastructure based on any x86, any storage, any IP network, and run their own custom applications. They can replace the infrastructure, replace any piece very easily because they have a platform which sits right between the application and the hardware infrastructure itself, which effectively manages the underlying infrastructure and provides abstraction and APIs into the application itself. Now, while every enterprise is not like one of the large, massively scalable data centers, the VMware SDDC stack with NSX, the SDDC platform, can offer customers the same benefits, where you can run your application on any infrastructure, whether it's a converged, hyper-converged, or build your own infrastructure very easily, because now you have that abstraction layer of the SDDC. In fact, a lot of the things we are doing within the software-defined data center are really not very new, right? We are taking what we have learned with virtualization over the years and extending it. What does that mean? Today, with server virtualization and virtual machines, the intelligence is already in the virtualization layer, right? You have now this vendor-independent x86 capacity where you can run the virtual machines on any compute x86 platform. You can programmatically create VMs, you can delete VMs, you can move VMs, you can snapshot, you can do several operations, and you can do that programmatically or through UIs. However, networking and storage have really been in a manual configuration mode because that's where the intelligence has been in the hardware itself. With SDDC, you can extend that same model to virtual networks and with virtual storage. For the remainder of this discussion, we'll be focusing on the networking aspects of the SDDC, which is what NSX tries to solve for. So what is NSX? NSX provides a faithful reproduction of networking and security services and software. Now you would think, what does that mean, right? You can do operationally, you can do functions such as switching, where you're extending layer 2 capability, extending the same subnet across your infrastructure and beyond, irrespective of what the underlying fabric looks like. You can route between different tiers and different subnets. You can add capabilities like load balancing, distributed firewalling, VPN, security, and also provides us the ability to connect to your existing physical compute workloads. NSX does that by giving you the ability to chain these services together. You can chain them via policies, which group multiple different objects such as virtual machines into specific groups. You can apply tags to VMs, and these tags create a posture based on which a security policy or an availability policy is defined. Everything which NSX provides can be consumed through a management plane which consists of a UI, which consists of consistent APIs which enable you to provision an entire network infrastructure in a matter of minutes and seconds without having to actually physically go and touch each and every single device. Now, while NSX provides all of the services over here and more, you can actually take and replace some of the NSX services or augment some of the services with a partner service. For example, you can, while NSX provides a really powerful distributed firewalling capabilities, if you need capabilities for the next generation firewalling, you can introduce a Palo Alto firewall which talks and integrates with NSX. You can use load balancing capability from a partner such as F5, and you can all connect to physical networks directly through NSX or with partners such as Arista, Cumulus Networks, Dell, so on and so forth. So a rich set of capabilities. Now let's take a look how these capabilities instantiate themselves. How do you start? Right? You start with your existing physical network. And this could be your existing network. It could be a Cisco-based fabric based off your Cisco Nexus 7000s or the new Nexus 9000s. It can be an Arista-based, Brocade, your vendor of choice. You start with your existing physical network, and you add servers around it. Each server has a hypervisor. And as a part of the hypervisor is a vSwitch, the vSphere distributed switch. NSX works with the existing vSphere distributed switch, which has been available in the market for many years. Now, this vSwitch basically gives us a data plane. As long as every hypervisor has IP connectivity to every other hypervisor, you can actually have, NSX can actually build tunnels between them. NSX can establish the connectivity for building the virtual networks. Now, what does that look like? Here are some examples using functions such as logical switching, routing, load balancing, firewalling, and physical connectivity. You can actually build multiple class of topologies, right? You can build a 2-tier, a 3-tier fabric. You can have a fabric where your app and database server are in virtual, app and web servers are in the virtual space, and the database is physical. The possibilities are limitless. You can even build large scale-out topologies where you have more than 80+ gigs of bandwidth to every single application, and you can scale this out on demand. And best of all, you can consume this entire infrastructure through a cloud management platform, such as a VREALIZE automation or OpenStack, in VMware integrated OpenStack. And NSX provides the ability to give you one-click deployment for all these topologies. Now think about this for a minute. If you were trying to do this with your existing traditional network, what would this require? It would require one to go and manually configure SVIs on your switches, right? Create the firewalls rules on your physical firewalls, right? Apply ACLs, go to your load balancer. You'll be touching multiple different devices just to create a new topology. You can reduce that work and automate your IT down to seconds and minutes. This is a very powerful capability. And because of this capability, we can solve a variety of different use cases. Here are some of the key use cases we are seeing as why NSX is becoming the strategic platform for the next generation data center. Number one, let's talk about automation. Because NSX can be consumed and allows you to chain all these services via APIs, via UI, and has integrations with various different automation products, you can provision capacity on a physical infrastructure on demand. You can reduce that provisioning time, which can take hours and days and takes multiple different people to actually touch and open a ticket, down to minutes. Secondly, and most importantly as well, right, you can also, NSX integrates out of the box with self-service infrastructure as a service products such as VREALIZE automation, or allow you can build a developer cloud with the likes of OpenStack day one. Another very critical use case, one of the more popular use cases around NSX, is around security and microsegmentation. NSX makes network security within the data center perimeter feasible. This has been a very hard problem, right? Security has been largely perimeter based, and everything within the data center is largely open. NSX allows you to secure east-west traffic within the data center. And of course, beyond the data center, because now we have the ability to extend the networks, just as we have the ability to extend the networks within the data center, you can simply extend the reach of NSX across metro sites, as an example, where you can now have active data centers. You're able to migrate workloads across those data centers. You're able to tie into scenarios such as disaster recovery, fundamentally reducing your recovery time objectives significantly. And we'll be talking about all of these use cases in a little bit more detail as we proceed through this conversation. Let's take the first one, NSX and its application to microsegmentation, right? So before we start, let's kind of understand, why do breaches actually occur within the infrastructure? When we look at these breaches, many of them seem of a very similar nature, right? Today's data center, as I mentioned earlier, are protected by a strong perimeter defense, where you have a group of firewalls, typically 2, which are protecting, deciding who comes in and what traffic leaves the data center. It is very hard to actually have firewalling internal to the data center without adding a significant number of firewalls, right? And in spite of this perimeter model, threats and exploits are still affecting servers. Typically what happens is an attacker would identify a low priority system, a system which may not be as tightly protected, which is open. Think of this as a desktop or a virtual desktop or something like that, which a person gets attacked through some kind of phishing attack, right? Social engineering effectively. The system gets compromised, the threat goes and establishes itself in that system, and it lies dormant for a moment to strike. Once the threat is activated, it moves laterally, looking for open ports, open vulnerable devices, vulnerabilities within operating systems, so on and so forth, and starts affecting other systems within the data center, which might be more critical systems, and then goes off to sleep again, right? Slowly, as time passes, it would start siphoning the data and pushing it out to places where people, and basically shipping it outside the data center and stealing the data itself. At this point, that threat has actually established itself in many critical systems. So what can you do to avoid it? The one way to avoid it, and probably the most best way to avoid it, is to microsegment the data center into objects which can only talk to who they need to talk to. This means establishing a east-west perimeter of security within the data center itself. Only the assets which need to have communication on the specific ports can talk to, and everything else is locked down. This is a zero trust model of security. Now, this has been operationally very hard in the data center. Think about in a traditional networking model, right? Traditional networking model has been built on the concept of having layer 2 sprawl everywhere, right? So that you can actually make it easy for workloads to migrate across switches, across top of racks, across racks. And that has been an easier way to do it. Trying to build security on top of this layer 2 infrastructure is very hard, because now you have to do enforcement via stateless ACLs, right? And these access control lists tend to get long if you really want to do east-west security. Or you can add expensive hardware-based firewalls. But at the end of the day, this is still a very static security model, where if you want to make any changes, these changes have to actually, you have to go to a particular switch or a set of switches or firewalls and make those changes. You cannot react to these changes based on the threat level or things of that nature. So microsegmentation with NSX actually can help. For example, you can create a 3-tier app with a web app and a database tier, and have these tiers distributed into logical switches with different IP subnets. You allow communication between them via a distributed router, which is also created using NSX. And then on top of that, you can layer in NSX distributed firewalling capabilities. Now think about what we are doing over here for a minute. All of these services, switching, routing, and firewalling, are distributed in nature. We are enforcing and building these services right in the hypervisor kernel, closest to where the VM resides, right? So now you can make the lookup, you can do the enforcement right in the same path. The distributed firewall runs in the hypervisor kernel, giving you 18 to 20 gigs of firewalling performance per hypervisor host. That is a very high performance capability. And you can do full rule enforcement right there at the hypervisor layer itself, allowing you now to secure communication between the web tier, the app tier, the database tier. You can lock down who talks to the web tier, on what ports the web talks to the app, and the app talks to the DB. Effectively, what we are doing is reducing the attack surface for every virtual machine. You can now create higher order security policies which are now tied to the application or project lifecycle. So effectively, somebody could request a new set of applications, those are deployed, and once the application is retired, the firewall rules associated with it, just as the VMs go away, the firewall rules and the switching and the routing constructs associated with it also go away. This is very important. Many times when you look at physical infrastructure, the VMs may go away, but the rules associated with that VM, the firewall, and the networking policies stay and live on forever, because very rarely are all of these things tied together and the ticket flows in the same way, right? So you can actually align these things, keep your data center from operation perspective simplified over the life cycle. Most importantly, each hypervisor from a performance perspective is giving you a firewall performance at line rate, very, very high performance. So with this, NSX can deliver better security with microsegmentation. Now let's look at three aspects of what microsegmentation really is. Number one is the ability to isolate different networks. Think about this. You can have a production network, a test network, and a development network, or a dev, test, production network, right? You don't need these three networks to talk to each other because they are created in different silos for a good reason, and you're simply moving the application lifecycle through these networks. You can completely isolate it by putting these networks on complete different logical switches, which are programmatically instantiated. Now, if you have a web, app, and a database tier within the application itself, you need the web tier to be able to talk to the app tier, but only on port 8443. You need the app tier to talk to the database tier on very specific ports. And the web only needs to talk to the outside world, but not to the database tier. You can create rules like this and policies and associated with the application. And every time you instantiate a copy of that application, those rules are automatically created and managing the lifecycle. Now, in some cases, you may decide that I need a higher level of policy, a higher level of security with somebody like a partner or a next generation firewall, for example, to protect where my critical data resides, like my database server or some other set of security partners. Here is where NSX extensibility comes into play, where NSX can actually forward the traffic based on certain policies, based on certain rules, to a partner firewall appliance like a Palo Alto Networks or a IDS IPS from McAfee, and so on and so forth. So you can augment the existing application, the existing capabilities using the partner of your choice, right? And that's what microsegmentation is. Microsegmentation provides that isolation, provides a segmentation to selectively allow communication between tiers, or segmentation with advanced services where a certain partner may be able to augment the capability in itself. Now with this, let's take a look at what customers are really doing, real world examples. People are using microsegmentation to build DMZs, right? You can actually have a DMZ where you can actually build a DMZ completely in software. This would have been operationally very, very hard in a physical network where you're actually building separate infrastructure, carving out separate racks, switches, firewalls for DMZs. you can create a DMZ on demand in software, completely isolated from the existing infrastructure, or provide selective communication. Or if you want to be able to provide multi-tenancy, you can have 2 tenants who are completely isolated from each other. And that's the capability of the power of microsegmentation. Now, another emerging example of a use case which we are seeing very commonly is in virtual desktops. And there is integration which NSX does with VMware's VDI product line, Horizon View. Why is this important? So with VDI or virtual desktops, a lot of end user desktops have started moving back into the data center. Now, data center is also where your critical applications reside. Now, these are typically more vulnerable systems because end users have access to them. They typically access the outside world, and they could potentially get affected. Now, we do all the right things to protect them, but they could get affected, right? And securing VDIs becomes harder because now you have these VDI pools and you have to create these long set of rules, and these threads can move laterally. Now, with microsegmentation, whenever you're creating a new pool of users, say you're a new conference and you want to add 500 users, a pool of desktops for 500 users for this particular conference, you can actually provision the security rule associated with that pool right there and there. And once the event is over, those can be pulled back. And using microsegmentation, you can continue to use your existing resources because now you have a guarantee that you have firewall policies and rules in place which are enforced at the VM level, which make sure or ensure that the traffic from a virtual desktop doesn't move to a critical application. And this has been a use case which customers have been deploying quite often. Take a look at this example. You can have a group for shared infrastructure, a group for virtual desktops, and group for virtual enterprise applications, all of which are tied together. With NSX, you can create these firewall policies based on these logical groups. The distributed firewall functionality within NSX provides you the isolation and segmentation, and at the same time allows you to get really good third-party integration, which is important with tools such as antivirus, vulnerability scanners, IDS, IPS, and you can programmatically deploy security on top of your existing infrastructure. So we have seen 3 important use cases of microsegmentation: DMZ, multi-tenancy, and virtual desktops, right? And what microsegmentation with NSX gives you is better security for your existing infrastructure, allowing you to enforce east-west security within the infrastructure. So now let's talk about the second use case, which is about self-service IT. So the biggest reason, one of the big drivers for IT today is around automation of IT, because it accelerates the capability with which IT can create services for internal users. Now, there are a few examples of how IT can be automated. Excuse me. One is the IT admin, right? End users are creating internal tickets requests for certain class of applications. These applications, the IT admin gets the ticket and typically provisions, somebody forwards the ticket today to provision a VM, somebody else provisions the networking, somebody else provisions the security, the load balancing admin would provision the load balancer. Now, with NSX integration with IT automation tools such as VREALIZE automation, what we can do is we can create predefined templates. So when a user requests a certain set of application, the administrators can come together based on their policies and create a template. The template looks like a blueprint which has the networking, the compute, the storage, the load balancing, and the security aspects all tied together. And then with one click, either the end user or the IT admin can deploy this entire template for the end user. Now that is a very powerful tool. Now, in some cases, such as the developer cloud, end users may be sophisticated enough to be able to create their own templates, in which case NSX integration with tools such as OpenStack or VMware integrated OpenStack can allow users to drive their custom topologies. These two are examples of how you can drive IT automation within an internal IT organization. Cloud providers are also using NSX to be able to create community clouds. right, to be able to create clouds using NSX as a part of their existing infrastructure to provide infrastructure services. Additionally, you can also drive NSX through API and create your own custom tools which sit on top of it, right? So NSX provides solution for every level of IT automation as a enterprise may desire to go with. Let's take a look at the integration with NSX and VREALIZE automation. NSX provides services such as switching, logical switching, distributed routing, distributed firewall, distributed load balancing. You tie this with the VREALIZE capabilities of being able to have a catalog which drives a cloud management platform which is driven through blueprints. What NSX provides are network profiles which define what kind of a network you're building. It could be a private network, it could be a routed network, it could be a NATed network as an example, right? And security groups and security policies which define the security posture of an application. And these feed into the multi-machine blueprint. The blueprint has networking and security, compute, storage, load balancing, all of these policies come together right in that blueprint. And as it goes in the cloud management platform, the entire application can be deployed on demand. So now you have a web tier, an app tier, a database tier with firewall policies, tags, load balancing, all of these policies associated with it. And if a user requests multiple different copies of this application, rest assured, every time it is deployed in an exactly identical manner. You can obviously customize your IP address, your IP pools, and things like that, right? But at the same time, the application is deployed in a repeatable, consistent manner from a security policy perspective. That is very powerful. Let's take a look deeper into what this looks like. So you have a network admin would actually create the external networks you would talk to, as well as the network profiles, and add that to a blueprint. A security admin would say what kind of security groups they want to align this application with. You could deploy every single application in its own fenced-off security group, so it has a security policy associated with it. You can apply tags to a particular security group, which define what kind of application is it. So during the life cycle, day 2, right, if the security posture changes, the application posture can change. And you can apply load balancing policies, create which of these VMs are tied to which pool, what kind of load balancing are you doing, things of that nature. Now, good thing is you can deploy the application in a particular construct day 1. But day 2, you may want to add more capacity of, say, web VMs, which means you need to also add these VMs to a load balancing pool. Because this has been tied to the blueprint, you could go back to VREALIZE automation, add a set of web VMs to a pool, and automatically it will talk to NSX to be able to extend the set of the load balancing pool itself. So not only are we looking at day 1 of how the application is deployed, but we are able to manage the life cycle of that application. Once the application is retired, all of the network profiles, the security, the load balancing VIPs, they are automatically withdrawn and the resources are freed up. Just as the VMs are freed up, the networking resources can also be freed up just as easily. This is a very powerful use case for self-service IT, because now what it does is you are able to manage your resources, you are not having wasted resources, and you can get a much better utilization of your infrastructure. So that's about self-service IT. Let's talk about the third use case around disaster recovery and extending beyond the data center. So what are the challenges with data center extensions today, right? If you have 2 data centers, and if you want to be able to extend your applications between these data centers, whether they're an active site, metro sites, typically customers require the need of extending layer 2 or IP subnets between 2 data centers. The technology required for extending IP subnets between data centers has typically been something like a Cisco overlay transport virtualization, OTV, right? Or an MPLS, VPLS circuit, or VPLS or GRE, or dark fiber. Many of these solutions, the first 2 over here, require specific hardware or capabilities which a service provider provides, which make it extremely expensive. Dark fiber is quite expensive because now you have to have that amount of capability available between the data centers and have to manage it as well. They are expensive, they are manually managed, right? If you make a configuration change, you have to make that configuration change consistently on all sites, right? And that's why it is hard to do this in a dynamic model of where the data center is actually going today. Now, with NSX, we have this ability to extend layer 2 within a data center. We can do the same across data centers using a logical switch extension, using VXLAN to extend that layer 2 across 2 data centers. Or you can use the built-in layer 2 VPN capabilities which NSX offers, allowing you to have an instance of an application across data centers, right? And this solution can be done completely in software on a per application instance basis, where you can have logical switching, routing, and distributed firewall across the 2 sites. You can do this with single NSX instance, multiple NSX instance, multiple virtual centers as well. And you can use the same capability, for example, the layer 2 VPN capability, to extend those workloads across a private data center to the service like a hybrid cloud service like a vCloud Air, allowing you to be able to do multi-site data center extensions today at the click of a button. This is very powerful. Additionally, you can also optimize how the traffic leaves the 2 sites, right? You can do egress localization of this traffic, and you'll be able to find more information on other discussions we have had on NSX multi-site extensions which are available today. Now, this is a great capability to be able to do active-active workloads. But many of us are also required to provide scenarios where we are able to provide disaster recovery for your operations of your infrastructure itself. So in case of a disaster, SRM today allows you to move the workloads, your VMs, and connect them to the other side. You can do storage replication, synchronous replication, so the storage is available for the VMs. Using NSX, you can even now move the network over, right? You can do this to provide instantaneous availability of those applications using disaster recovery. You can fail over the switching, routing, the firewall rules, and don't have to re-IP your applications. This is very powerful. Let's take a detailed look at how this works. So what do we do today? It's a very simplified view. Say you have a VM on your primary side, and you have a recovery VM available on the remote side, right? You're going to take a snapshot of the VM. You're going to basically replicate the VM, the storage to the other side. In case of a disaster, the VM is actually recovered. It is booted up. And now you have to bring it up. Typically, this is where the manual runbook part of the operation starts, because you have more than one VM, right? So now you're going to have to re-IP the VMs, assign them the IP addresses. If there are load balancers, security, firewall rules, open those, re-advertise the routes. There are a set of manual tasks which have to be done for a network perspective. Those are the hard part. We can dramatically simplify this using NSX. So let's take a look. Now, just as you're able to snapshot the VM, you're replicating the VM and storage. Because you have the state of the network using workflows, we can snapshot the networking and security posture of that VM and basically have it ready for you on the recovery side. Now, if there is a disaster event or you're doing a disaster test, you basically recover the VM, the network security already exists, you associate with the right vSphere VDS port group, and lo and behold, your network is up and running. You don't have to change the IP address. You're simply advertising the route from the next site, and you have been able to basically reduce the time it took to recover that VM, recover the application almost by 80%. Many of the manual tasks don't exist anymore. The entire process can be automated, and you can fail back, fail forward, and you can automatically keep capturing the state of the network over time. So with this, we have seen 3 important use cases: microsegmentation, self-service IT, and disaster recovery, right? All of these 3 use cases can be delivered using NSX. Now, NSX is also a key part of the converged infrastructure offerings by VCE, by EMC. And let's talk about why this matters. So when you look at where the infrastructure is going today, right? With SDDC, you can have an infrastructure which is a build your own infrastructure. You buy the servers, you buy the network, you buy the storage, and you integrate these things in-house with the help of a partner or through your IT staff. or you could buy a converged infrastructure, a validated system which is rolled in as a rack with compute, storage, and networking as building blocks. Or you can buy a hyper-converged infrastructure which also includes the software offering on top of it. With a software-defined data center offering by VMware, you could run a layer which allows your applications to run on any of these kind of infrastructure offerings without having to modify the application, without having to worry about what the underlying infrastructure looks like, because this SDDC is your abstraction here. So whether you're running today's applications, whether you're running platform as a service, whether you're running containers, or whatever kind of application, or whatever kind of infrastructure stack you choose to build in the future, the SDDC stack, the SDDC platform with NSX will ensure that wherever application goes and however infrastructure evolves, the SDDC stack will be ready for you to give you the flexibility to run your application on any converged infrastructure offering. Right? This is why converged infrastructure and SDDC is a marriage made in heaven. So let's talk about what NSX and VxBlock. VxBlock is a new offering from VCE, which is one of our federation partners, right? With VxBlock, you have the option to have NSX pre-installed in the factory on a VxBlock. When the hardware ships to you, you have the NSX managers, the controllers, the edges, all components of NSX already pre-configured. You can log on to the UI, and you can start deploying services which use NSX right from the minute the hardware rolls into your data center itself. It's a completely validated architecture based on a best practice reference design. It's based on Cisco UCS, Nexus 9000, ENC storage, vSphere, and NSX. It is fully supported by VCE with availability in early Q3. There are various reference designs also available based on which the architecture is built, and you can find them on communities.vmware.com/NSX. Similarly, the VxBlock vBlock offering is also part of the Federation Enterprise Hybrid Cloud, where you can actually have the full validated stack with offerings for self-service IT along with VREALIZE and NSX integrated for disaster recovery available. All of these solutions will be available to you as a complete solution offering as well. So NSX can be procured as a part of reference architecture infrastructures, converged infrastructure, right? So key takeaways out of this discussion. There are specific solid use cases you can solve, your problems which can be solved with NSX, such as building a better secure infrastructure, being able to deploy your applications quickly within your infrastructure, creating a more highly available infrastructure. It's a foundational piece of the software-defined data center offering by VMware. And you can procure NSX as a part of a validated architecture as a part of a converged infrastructure offering. With this, thank you for your time, and you hope you get to try NSX either in the hands-on labs or visit us on www.vmware.com/co/NSX. Thank you.